Hello, I'm Aiden Goschel, and today I'm going to be talking to you about my SURP project, which is a verification of contingency dependent augmentation, or CODA for short. And that's basically just the state-space learning model that we developed. So for starters, I just kind of want to explain what state-space learning is. It's basically the ability that us humans have when we're navigating through environments is we can construct this like mental map in our head. And with this mental map, we can position ourselves in an environment, and that's basically all that state-space learning is. It happens automatically, but sometimes it can be a little difficult. So, for example, suppose you're in a room that has no identifying features. It's basically just four white walls and two identical doors. And you can go through these doors and you'll reach a room that's exactly the same as the one that you're in right now. And you can keep going through doors until eventually you reach a terminal room or like a last room. And in that last room, you're either going to be rewarded or you're not going to be rewarded. More on that in a second. These types of environments are basically exactly what Coda is designed to learn and to learn accurately. And when I say learn accurately, we're testing specifically the model's ability to identify a specific queue room. So I mentioned a reward. The reward, you only get a reward if you pass through a specific room on your way to get to the last room. So it's basically able to answer the question of which room do I need to go through to get a reward all the way at the end. Um, so to extend the current work that's been done, we want to test this model in converging and diverging environments. So converging environments are environments where you can start from a multitude of places, but the environment ultimately like converges into one singular last room. Whereas diverging environments, you start at one room and it diverges and you can end in a multitude of different locations. So to talk a little bit more about our results, Coda is actually able to learn the structure of diverging environments, which is great. It accurately identifies the queue. However, it's not able to accurately and consistently identify the queue in converging environments. So in light of these findings, we thought, okay, maybe introducing some sort of like a probabilistic structure into the environment could be good. So what that means is basically when I pass through the queue, rather than me always getting a reward at the end, maybe now there's like a 70% chance where this percentage of being or like the percent chance of being rewarded can be changed. And we found that for no matter what percent of reward or likelihood of reward, Coda learns an unstable representation. So the representation changes every single time you run it, and it's not able to consistently and accurately identify the queue state or queue room in this case. Anyways, thank you so much for listening to my proposal project.